Hello and welcome. I'm Bill Wake. We're working on a basic interpreter. We've done most of the work on expressions except for arrays. We're kind of in the middle of that. We've got one-dimensional arrays working pretty well. We did some testing though at the end of the session, and the corner cases of out of bounds. We got out of bounds on the right-hand side working, but we need to check for bounds on the left-hand side. Once we get that done, which shouldn't take too long, we'll go ahead and generalize our arrays to multi-dimensional arrays, so more than one dimension. And it's not too, I don't think it's too hard. Let's see. So how's that work? Well, if you have an array like A here, it's A sub 2, 4. In BASIC, which surprised me, it's zero based, but it goes up to the number you say. So so you don't give it the size. You're not telling the size like you would in C or many other languages. You're giving the maximum bound, and the minimum bound is always 0. So this array is a 3 by 5, row 0, column 0, row 0, column 1, and so on. That's a normal two-dimensional array. We want to handle any number of dimensions. I mean, most problems are going to fit in 1 or 2 or 3, but we're not trying to put a limit on it per se. And what we could do that with map one-dimensional arrays to 1D, two-dimensional arrays to 2D arrays, 3D to 3D, and so on. But that requires an arbitrary number of maps from the basic type to the Swift type, since we're interpreting in Swift. And so we want to do more of a formula to linearize our table and basically look like on the bottom. So 0, 0, 0, 1, 2, 3, 4, row 1, 0, 1, 2, 3, 4, row 2, 0, 1, 2, 3, 4. And the formula for this is the slot number, so like 0, 1, 2, 3, 4 on the top of that linear section. For A at row column is the row times the dimension, the first dim 1, which is the dimension of the second thing. We're counting our dimensions from 0. So A sub 2, comma 4, dim 1 is 4. Okay. That should be 3 here. Oh no, 4. Yeah, 4 is the max. Okay. It's going to throw me off all day. Okay. But well, actually, the dim 1 is actually 5. We want the count. So you're going to multiply the row times 5 and add the column to it. So if you want row 1, column 3, you can take row times 5 is 1 times 5 plus 3 is 8, slot 8, and there it is, 1, comma 3. So everything kind of adds up. And the nice thing with this is it generalizes. So if I had a three-dimensional array, my formula is R times dim 1 plus C, all that times dim 2 plus the Z coordinate, okay? It works out. So we get a linear array in each case. You have a choice about, they call it row order or column order. And I forget which one we're saying here. I think, I won't even guess because I'll get it wrong. I always get it wrong. But we could have tried to. Here we're varying the row number the slowest. So the 0 slot 5 is 1, slot 10 is 2, and the column number is varying on each individual one. So it's an option. All right. But like I said, we got a little work to do first. So where we left off, let's see this test. Yeah. So if you don't dimension an array, it's implicitly lower bound is 0 and the upper bound is 10. So A sub 11 equals 5 is out of bounds, and A sub minus 1 equals 27 is out of bounds. So we expect that to be reported twice. I don't know. We might be better off if we stopped after that and just crashed it, but we're saying this. Okay. So when we go to do this, let's see. Well, we hit an index out of range. Okay. And if we go to the interpreter, okay. Array access. Well, it's interesting. We actually want to look at assignment. Is this assignment? No. Let me look for assign. Because the problem is well, let me look over here for assign. Oops, do assign was right. Okay, so array access, we definitely have similarity to what we saw above, but let's see here. Where's the assignment? Updated values equals values. I think we're probably dying at this line, maybe. No? Okay, let's run this and make sure. Oh, this is array access. I thought we were doing the assignment one. Okay, this test is okay. I'm looking at the wrong test. Check bounds check array right. Yes, that's the one we want to. Okay, so line 588. Why that's 588? Oh, continuous array buffer. Okay, but it's 383 here. All right, so at this line, index out of range. So let's see, index is 11. So this assignment to a sub 11 is out of bounds. And then let's compare the code to what we had in the evaluate. There we go. Okay. Here we create the default array. Here we check. Let dimensions, let values, try to subscript non-array. Okay. Evaluate the expressions as float. Okay, here we go. We've got the expression, the index, and then we check. If it's less than 0 or greater than equal dimensions, then it's a problem. Okay, so we want similar code, and we'll refactor in a second here. Okay, so it was 388, 33. Okay, so we got index somewhere. Well, let's drop this code in and we'll figure it out. Okay, index. We calculated it here. Okay, yeah, let's put this up here then. Okay, so we evaluate the expression. We check if it's less than 0 or greater than equal to dimensions. Well, dimensions we don't have, so we got to find that. And I think it's array access might have it. String, it has the type. Oh, we had to find that first then. Array access is string, result type, and expressions. We should have looked up. Sorry, bouncing around this morning, aren't I? All right. Oh, okay. Here we get the globals. So we look up the array. If it doesn't exist, we generate it. Okay. And then we check that. Okay, I guess we are down here. Because globals, sorry, the updated values. Let's check the types there. Updated values is array of float. Oh, here we got dimensions. Okay. So it's okay to check down here. Yeah. Where I had it in the first place. All right. What's the matter? Can I convert value of float? Index with int of index. Well, do we ever want index as a float? Not really. So let's do this up here. Okay, now our index is an int. And dimensions? What's the matter with that? Type member has no string. We're returning a string. I'm not fully happy with our error handling still. We looked at it a little. Okay, string. Oh, I'm editing this while it's in failure mode, so that doesn't help anything. Okay, so down here, this int of index, we move that up. All right. Okay, so we evaluate the index, get the integer form of it. If global's name is nil, meaning the array doesn't exist yet, we create it. Then we use it. It should be an array of numbers. Okay. I don't think we should end up here. No, that's just offset. Okay. But here we have dimensions and then reference it here. So I think that should be fine. And then we're updating the values and sticking it back in the global. Okay. That's all right. All right. Let's see how this test does now. Okay. Monday. Okay. We saw array access out of bounds. We only got it once. Yeah. I think that's actually correct. I think we need to split this up. Well, let's do it this way. And I don't mind putting them both in here. Okay. All right. Let's try this again. Okay. Rex, oh, there's no new line. That's because there should be a new line. I think. Like I said, we've not. I mean, that seems to be consistent. Oh, do a sign. Okay. Yay. All right. Okay, let's push that at least. Okay. Check array bounds on assignment. Okay. All right. Now I think we just have some cleanup to do, and I don't know. I feel like all right. So evaluating the index, evaluating the value, that seems all right. Where's R value here? L value and R value come in. Okay, we're saying expression equals expression. Or actually variable or variable with subscripts equals expression is how we get here. Okay. Evaluate this, evaluate that. Check for the array. Now this bit of code is in there twice. It's also very similar to how we handle dimensions. Do dim. Well, actually, I don't like the output in here. We really execute this code for side effects, and the fact that we're just returning this output as if it were the input, that's really not interesting. Okay, so let's find it again. Do dim. Okay, let's just call do dim and return output. Okay, and I didn't run all these. I can tell it's morning. Okay, result is unused. Good, because we're gonna. Well, so much for that. Dim may not redeclare variables. Oh, yeah, like I said, I don't like the output. Okay. Right. So dim is returning this string. I'm definitely not happy with this. Okay. How can I do this? I want to get green and then deal with this. I want to do a throw here instead. Okay, so let's make this, let's get rid of this and let's just say throws. Okay, and then we don't need the return output anymore. Okay, now I think we have, well, I don't think we have any runtime errors here. Okay, so in the parser we have errors. I don't like these. Okay. Yeah, let's get the parser. So up at the top here, we got all the errors that can happen. So I think we want to do the same kind of thing, but we're gonna have a runtime error, and well, yeah, I think that's gonna be an improvement if we make errors more explicit this way. Okay, and I want to do them all. So I don't know. Maybe we're going to not get as far as I wanted today on the multidimensionals. I think this is a real problem. Okay, so I want to take one step to get it better. We don't have to do everything. Okay, let's find do dim again. Do I have a fold? Let's navigate, right? Jump to last destination. I don't understand why there's not a thing for that. Editor. Okay, folding. Fold methods and functions. Yeah, let's do that while we're doing this stuff. Okay, call can throw but is not marked with try. Yeah, we want to do that. Okay, so do dim. We're going to say do catch this becomes a try. All right. And yeah, what are we going to do with these errors? Well, I think we're going to append them to the output for now. I think that's what we've been doing. We got to give this thing a name. What's the case? Well, this is array access out of bounds. Okay. Where's dodim? Okay. Catch. I think array access out of bounds. I think I could just say error here. Okay. Yeah. Errors thrown from here, not handled because, okay, let's just do a catch. Whatever error you get. Cannot find error in scope. Okay. A result of dodim not used. It's left side is not mutable. What are we? Oh, I guess we're doing output plus error. Yeah, we're going to fix that one of these days too. Can I convert error? Can I do this? Okay. This will fail still. Okay, let's run them all. The dodim case is going to fail. Oops. Oh, right. Let's throw array access out of bounds. All right. Run again. At least that one. Whoops. Type error. Am I misremembering how to do this? Happens. Case interpreter error. Do I really have to say interpreter error? We did this in parser. Throw error. Well, that one knows it's a parse error. Oh, I do have to be explicit, apparently. Okay. So I'm going to accept a little worse message. Except, wait a minute. Where's dodim? Okay. If global's name, it's not every access out of bounds. It's it was something not found, right? Dim may not redeclare. Is that it? Yeah. Can't redeclare. Okay, so this is can't redeclare array. still going to fail, but at least let's get it failing for the right reason. Okay, and this text is going to change now. Okay. Yeah, we're just going to get the error text in there. Again, I'm not trying to solve everything. I'm just trying to get a little better at this point. I think we'll probably have to come in and spend a whole session on just cleaning that up. All right. Let's see. Start to throw exceptions instead of just appending error messages to the output. All right. Now do dim. All right. It doesn't need the output because it doesn't use it. So let's take this argument off. Okay. Here's the call. Okay, output isn't needed. Okay. It complicates this. I mean, it was easier to just ignore it, right? But I think it's better. At some point, all these catches we'll probably have to. We'll do something better, but yeah. Okay. So now the nice thing is do dim. You give it a name in the dimensions you want, which I think is the +1, the size, and it detects if you try and redeclare, and then it goes ahead and gives you an array of the proper size and puts it in the globals. Okay. So definitely done for its side effects. All right. Now I want to say do dim this routine. See, it's much more, this routine is now more single purpose. It's focused on get the new array created and in the globals, and if it can't, it can't, but it really wants to do that. And the decision about what to write in the output, if it can't happen, that's elsewhere. So we've, I guess you could say single responsibility principle. It's more close to that, but I think it's more focused on its, the real work, which is usually an improvement. All right. Now we have two places that could use this. One is our array access, which is an evaluate. Okay. Variable array access. Okay. If the name is not in the dictionary already, okay, then we're going to do this stuff. Well, this stuff is exactly the stuff that we do in do dim. So now the name, maybe do dim should do even less. Let's do that. Let's make it. Let's move the error checking out. Okay, so I'm gonna pull this up to the call for do dim. All right, so here. All right, and does this function throw? It does not. Okay, so we'll do it this way. If the global name is not nil, then you're redeclaring the array. Okay, that's a decision we're making here. All right, and assuming the global name is nil, then we will go ahead and do dim. All right, and then if there's an error, we'll return the output. Otherwise, we just pass along what we had. Dim is normally it's executed for its side effects. All right, now down in dim, okay, this code is much more, it really is just like allocate the array and store it, okay? And that's what we wanted up here in evaluate as well. Evaluate is down here. Okay. Yeah, this array. I guess, yeah, we don't really need it because I was going to say we could return the array name or the array, but we've already got its name and we just look it up here and we know this is okay because we just did do dim that's going to make it okay. All right, so now this is do dim, the name is name, and the dimensions are 11, okay, the count and that. Okay, and there should, we got to take the throws off here. Okay, he no longer throws, he just does his job. All right, let's make sure that's okay. True. Okay, and then we can use the same thing down in our assign. Array access. Okay, if global's name equals nil, then we're going to do dim. Yeah, that 11's shown up a couple times. We'll come back to that. All right, are we actually okay? Bounce check. Yeah, we're still refactoring from the bounce check. All right, so this should all work. Okay, so I guess that's a refactor. Make evaluating a subscript and assigning a subscript. Use do dim if array needs to be allocated. Okay. All right, and then do I care? I'm thinking I might want to move these down. We don't reference index or value until down here, so let's move this down. Okay, so in effect, we're going to check the conditions around the array first. We'll dimension it if necessary. If we look it up and it doesn't have the right type, then we'll return that. Otherwise, we go ahead and do the stuff. Okay, now the stuff, let's take value and move it down. If we have an error, well, the way we did it just now, we index and value, and then we check index, and if there's an error we return, we ignore the use of value. So nobody's using value, it's safe to move it down a step. Okay, now index. Well, this is going to change. We got those evaluates. Okay. Trying to decide if, I mean, this check, like, this code looks very similar to the code in evaluate. All right, let's look at that. So calculate the index, check it. All right, and then evaluate. Array access, calculate the index, and check it. Okay, and See, this gets more complicated when we do multiple dimensions, right? It's going to be it'll be a whole situation. Okay. Let's see. So I think you could give me expressions and the store. Do I want to evaluate them? Yeah, I kind of want to make I don't know if I should evaluate them there. Because really this is going to become a map statement. We're going to map each expression to its evaluated value, convert it to an int, and then check its dimensions. And really what we're trying to do is get the index back. So, all right, let's try something here. So what I want to try is I want to say this is going to return an index, a valid index, or it's going to return and it's going to throw. Okay, so let's start making a method here. Okay, well, I'll put it down on the bottom here. Okay, so far it's file private function. This is index for something. We know it throws, and we hope it returns. I don't know what we hope it returns. Let's just get it in here and see what we think. Okay. All right. It must take expressions. So this is expressions is a list of expression. Okay. It needs to take a store. And it needs the dimensions. And those are what? I think they're array of int. Okay. So expressions, yeah, okay. Then this is the throw. Array exits out of bounds. Okay. But, well, do we want the index or do we want the value? We want the index because reading and writing need different things. Okay, so this returns an int. Okay. Okay. So I want to make both places use this. All right. So they're going to compute well, let's get the space so it looks like a real thing. Evaluate this as float. Okay. We can probably pipe that or map it or something. All right. So I think index for expression store dimensions should give us the right thing. Okay. All right. So this is index for expressions, store, and dimensions. All right, but it's got to be in a try. do this. I think we're doing this so far. Okay, so move this up. Okay, so if the array isn't there, allocate it. If it's not the right kind of array, something's weird. What value? Value is global's name. Oh, I'm just getting the dimensions and the values. Okay. Index, return number, subvalue, subindex. Okay. Otherwise, I guess we just returned a string before. Oh, this is evaluate, so it's not the full size thing. Okay. Should work. Okay. Doesn't even build. Okay. Cannot convert value expression of string to return type value. And this is kind of how I know things aren't quite right, because I'm flipping around trying to get these types wrapped correctly and stuff like that. We'll see. I think this should pass. I'm not sure why it's so slow. Okay. One failure. Bounds check array access. Okay, I can believe that. Okay. So, yeah, this has changed. Now, and again, I'm not sure I like the, oops. I'm not quite sure I like the approach, but we're just documenting what we're doing and nudging it a little bit forward. Okay. So, made common routine to fetch and validate index for subscripts. Okay, now interpreter. Okay, we can clean this up. Okay. Our assignment now, do assign, okay, has a similar thing, right? Oh, do assign. Okay, so we're going to say do. Okay, and in here, this let index thing is going to be our index for. Index for expers. The store is globals and dimensions. Okay, and then we don't need these anymore. let's make sure this works, and then we'll walk through it and make sure it's plausible. No. Okay. Right. Oh, oops. Same deal. I'm sure. Yep. I'm not 100% sure about the new lines. Yeah. Okay. Oh, goodness. This expecting thing, I don't know why it's shoving that so far to the right. Run them all, just make sure. Okay. For array assignment, use common index for method. Okay. All right. Let's clean this out. Okay, and let's look how this goes. All right, allocate it if necessary. Check the type. Allocate if necessary. Check the type. Evaluate the index. Evaluate the right-hand side. Get the array and assign it the new values. Okay. And if there's an error, append it in. Okay. Default return. Yeah, we're still returning strings. Yeah, again, the output is not used really. I mean, it just gets returned here. Okay, I have on here something to deal with this. Make running right to an output stream. Okay, I don't want to be passing this around. I just want to pass a stream and you append some stuff to it. So we can observe it while it's running instead of waiting till it completes. Okay, but I think we've done the bounds check now. Okay. Yeah. He has the list of all expressions, all dimensions. I should mention this use of globals here. It's which store are you referencing? Are you referencing the global store, or are you referencing the one that's inside in a function you're evaluating? Well, this is the top level statement, and there's no way to use those in the evaluation function, so we know it has to be globals. Okay. All right. Now, okay. I think we're okay. Let's say we've done bounds check for now. Okay. We have to revisit it in a moment here when we do the multidimensional arrays. 22, 20, June 6th. Woof. Okay. Bounds check 1D arrays. And I said we were going to do multidimensional first. Interpreter format, enforce array types. So we've been doing some of that. These tests helper for parse-based tests and interpreter. Okay, well, let's see what those are about. All right. Well, we're due for a break, so let's take about a 3-minute break, and we'll come back and tackle these multi-dimensional arrays. The core of that, well, dim is going to have to allocate enough space for the whole thing, and then the accessor methods are going to have to linearize the multi-dimensions and go from there. All right. See you in about 3 minutes. Hi, welcome back. Alrighty. Let's see. Well, I go back to this picture all the time. Lexical analysis, we've already got commas, so there's nothing new to do there. We recognize the name, the left parenthesis, the commas, the right parenthesis, the expressions inside. However, we may have to do some work in parsing. So let's take a look at the parser. All right. And we want to find, well, the two cases. Three things. Yeah. Well. All right. Dimension, we have to be prepared to dimension multidimensional arrays. Okay. So the dim statement is a variable, a left parenthesis, an integer, right parenthesis. Okay. But if we look at our grammar down on the bottom, actually, I don't know if we have the dim statement in here. Statement dim. Yeah, we do. Okay. It goes to left parenthesis integer followed by optional comma integer. Okay. We don't handle that yet. All right. So we need to make that go in the dim statements. And then in the factor, we said you could have variable parens expression, comma expression again in array access. And then in our assignment statement, wherever that got to, let variable equals expression. Well, this one is actually variable optionally followed by left parenthesis expression right parenthesis. Okay, for the assignment of the expression. And then we add in repeat, comma, expression. Okay. So let variable parend expression, comma, expression repeated, parend, all that optional equals expression. Okay, so we do have some grammar work to do, or parsing work to do. All right, so let's find our parser tests and a dim. Okay, test dim. Test multi-dimensional dim. Check parsing. Okay, our program is going to be 10 dim a sub 3 comma 4 comma 5, and we should get back a line and then dim. Well, let's pick a different name. So I just mix them. Oops, I mix them up just so I kind of get some free bounds checking kind of stuff. And if I check A every time, I know A works. But if I check more stuff every time, then I got a better chance. Dim Z, and then this should be, what do we say here? Dim A5 got 6, so this should be 4, 5, 6, because we're adding 1 to do the count. 3 says make 0, 1, 2, 3 valid indexes, and so on. Okay, X dim, and then close the check parsing. Whoops, the line and the check parsing. Take it that? Yes, okay. And built this. We expect it to fail because it doesn't expect commas. Okay. And missing left parent. Unrecognized statement. It wasn't quite what I expected. Dim. Why did we get a missing left parent? Okay, I'm going to break here while we look at it. Okay, let's step over. Okay, let's print token. Oh, I guess we can just see it here. Token is variable, good. Let's skip over that. Token is left parent. Oh, we're getting inside it, but okay, I feel better. Okay, we got a. Oh, haha. My error message is incorrect. So we're missing a test here. Okay. Copy paste error, I'm sure. Let's do a check error statement as well. Test write parent error in dim. All right. I think this function is going to fail. Yep. Okay. So we're saying missing left parent instead of right parent. Let's fix that. Okay, now we run this one. We're going to get that missing right parent, but that's fine because what we got is a comma, unrecognized statement. Okay, let's add our commas then. Okay, so we require the left parent. We get the first integer. Okay, and next token. Now we're going to do a loop while comma is token. Okay, so we're doing comma expression. So we skip the comma now, and we're going to capture the expression. It should be an integer. Okay, so this is kind of the same deal here. Okay, and size. Right, we capture size down here, but instead I think we're going to let's add a result. Bar dimensions is empty, and then we're gonna store the size here. Dimensions.append size. Okay, and then same thing here. Dimensions.append size. Okay, so in the loop, we're catching all those. Oh, we're going to do plus ones. Dimensions, size plus one, and size plus one. Okay, so if you say dim sub 5, you should get 6 in your dimensions list. And if you say 3, 4, 5, you should get 4, 5, 6. Okay. Expected type. Okay. Dimensions of int. All right. Let's see how we do. Okay, good. So dim statement parsing. Okay, I'm going to abbreviate it from now on. Okay. And then we should be able to do the interpreter. Okay, do dim. Now, okay, you give the dimensions. So really, when we allocate the array here, dimension sub 0 is just the first dimension. We need to multiply them, right? Because if you've got, a 4 by 5 by 6 array, your size is the product. Okay. So let's do an interpreter test. Why do you keep finding that one? There must be a setting. I hope. Okay, knows type and size. Okay, yeah, this is the kind of function we're going to do. Multi-D array. Okay, so a sub 2, 5, 4 is 40. I don't want to type that 40 times. Okay. Let's see. This is. I hate to duplicate the. Okay, let's do 1, 3, 2. Okay, 6, 4, 5, 6. Okay, so if you dimension a this is 2 by 4 by 3. That's still 24. Oh, okay. Let's do 2, 1, 2. Okay, so that's 3 by 2 by 3 is 18. Not 180. Okay. Okay. I think that's plausible enough. All right. So if you allocate this, 3 times 2 times 3 is 18. right? 6 times 3, 18. Yes. All right. This is going to fail because all we do is dimension sub 0. Okay. And it's going to fail with 3 things in there, I hope. Yeah. 3, 2, 3, 0, 0, 0. It only put in three numbers. Oh. Is this holds the dimensions? Yeah, so I got to do that. Okay, so this is 3, 2, 3. And it was partly right. Okay. Okay. Try again just for. Okay, dimensions is right, and it's got the wrong number of values. Okay. It takes a little while to get the right failure sometimes. All right. So the count is well, it's really dimensions dot reduce 1 star. Okay, which means multiply all the dimensions together with a starting value of 1. So 1's the identity for multiplication, so this count should be correct, and then we'll use the count. All right. That was the easy one, of course. But yeah, so we've taken our first step towards this linearization. We said this was a 3 by 5, and turned into 15 entries, 0 through 14. And we've done the same thing. We haven't done this access stuff yet, and I don't know how that's going to look. All right, so let's go back to our parser. And parser tests. Okay. Test fetch from array. Yeah, let's repeat that. So if we, can I say ND in multi-D array? Okay, if I go a sub 1 comma 2, well, it shouldn't blow up because it defaults to 10 by 10, 100 entries. And this is number 0. What? Array access type dot number sub 0. I don't know. Oh, was I 0 before? Yes. Okay. Number 1. Dot number 2. This tabbing is just driving me bananas. Okay. a sub 1, 2 equals 10, print a sub 1, 2, type is number. And this should fail, assuming we don't handle it already. Yep. Missing right parend, which is the error we had before, so that's good. Parser. And this is on evaluate. Oh no, evaluates the interpreter. This is on factor. Array access. Variable. Token is not left paren, return variable. Otherwise, we require the left paren. That's fine. Require right paren. We need the comma thing here again. All right, and we need to gather the expressions. Okay, so var expers of type array of expression. It starts empty. Expers.append exper. While I don't know, this seems more natural to me. While token equals comma, skip the comma and do more of this. And then in the end, we're going to return expers. Okay. And I think that'll pass. We'll run them all. Okay. I guess interpreter. So now we want to look at evaluate. Evaluate. Okay, array access. Well, now we're passing in the expressions and the store and the dimensions, and we want to get this value should be our linear index, okay? And that gets used there, which is fine. We may have to do both parsings. Let's go ahead and do the other parsing. Seeing as they both share the method, then they probably both rely on it being the same. Okay. Do assign? Oh, that's assign. Okay. Same situation. Okay, so we will capture the expressions. Match the comma, skip the comma, do this. Oh, let's well, expert. Oops. How often do I do that? Okay. Oh, we have more than one problem here. Okay, let's comment this out. Expers. Let's make it expers sub 0 for now to make it like it was. All right. This should all be passing because I commented out the stuff. I just changed this slightly. Okay. Now, assignment. I'm totally messed up. Okay. Let's undo this file. Well, I'll diff it first, but where's that thing? Oh. Okay. I'm not sure how I see the changes. Well, did I change anything down here? I don't think so. Okay, let's just revert it. Discard changes. Okay. Go back to tests. Now they should all pass. All right. Assignment. All right. I got else if variable equals token try variable. Where's my, let's see. No, I'm messing something up. Okay, assign. Starts with a variable. All right. Case variable, let name token skip. Return variable. Equals. Oh, wait a minute. Does our code not work? If you do a parenthesis, I thought we tested this. A sub 1 equals 17. Okay, that's a different. Okay, assignment to array. Let me modify this test. I have a feeling we aren't doing the right thing. Okay, I'm expecting 17. Well, I'm kind of not expecting it. It should be 17 and 42. We printed a sub 1 and a sub 2. I have a feeling it's ignoring this. I'm not sure what's going on. I mean, we should pass this if things are working, but I'm not quite sure the parsing is. Okay, so it's me confused. All right, so assign. Variable. Oh, variable. Okay, this must have more stuff in it. Well, yes, it does. Okay. If, oh, we've already got it. Okay, because they share. All right. So, interpreter tests. Let's go back here. I guess the parser test is okay. Interpreter tests. Did we not do one? Okay, I guess we're ready for another test. Okay, so a sub 1 comma 2 equals 12. A sub 2 comma 1 equals 21. A sub 1 comma 2 2 comma 1. And we expect to see 12, 21. Okay. And this should fail. Oh, no. Oh, I know what to do. Let's do 1, 1 equals 11. A1, 2 equals 12. A1, 1 equals 11. Okay, because we're only looking at the first dimension, so I had two different ones. 11, 11 is not equal to 12, 11. So this one overwrote a sub 1, 2, because it only stores a sub 1. All right. And why are you over here? Interpreter. All right. Yeah, so now index 4. And I don't know how to... Okay, well, the real thing is the index 4 is just using the first dimension, and it should use all the dimensions. So let's go in there and fix that. Okay, we got the list of expressions. We got the list of dimensions. Okay. What we need to do is get the full set of indexes. So let indexes equal, and then we're going to take each expression. I don't know how people write this. Expers dot. We're going to map each one to this. Sorry, it didn't grab what I thought I did. Paste. Okay. Expressions. This is $0. Okay, so if we take each expression and evaluate it, and then map that to int of $0 dot as float. Okay. That should give us the array of indexes. Okay. And then, all right. So now we gotta check each one. And we can't just check the value, right? Because if the first one's out of range, it's illegal, even if the first one times the second is the whole thing, even if it points somewhere in the array, but it's an illegal expression, then there's no, it's not good. Okay. So I think this, the indexes equals covers this statement. Then I want to do a indexes dot enumerated. Okay, and that gives me the pair n comma x, which is the number. All right, and I've got to compare against dimensions sub I. Okay, sub n. Dot, and then I guess this is just for each. Well, is there a better way to do that? It's really okay. Let's do it this way, and then we'll refactor it. How's that? Okay, so this is I index in this. So index is less than 0 or index is greater than or equal to dimension sub I. Okay. Throw interpreter dot error outbound call can throw. Okay. Okay, so we'll try that. That should cover this and this. Okay. Now, we need to cover that linearization thing, and I don't know. All right, so this is slot ARC equals R times this times that, and I think in a way I'm doing an accumulation. So an accumulator is basically a reduce. Okay, so I think if you take the first value and then you multiply it and add dim1 and kind of index 1, then that should be okay. So let's see. So this is, I don't know if it sounds complicated or not, but I'm gonna zip two sequences. One is basically I want to get index 1 and dimension 1 and index 2 and dimension 2 and so on. And the first one is just coming off the front. Okay, so I'm going to say zip indexes dot drop first with dimensions dot drop first. Okay, so the funny thing in this calculation is you don't use dimension sub 0 anywhere. So if it's 2, this, or well, it's 3 in effect, we're not using that. We're multiplying by 5 and then adding. We don't ever use the 3 anywhere. Okay, so that's why it's a drop. I don't know why the formatting is so screwy. Have I left out a brace? Yes, I have. Okay, let's try that again. Okay, that's more like it. Okay, so if I drop the first on each of those, and then I'm going to do my reduce. My initial value is indexes sub 0, okay, which is what I dropped. And then to get from one to the next, you're multiplying. So multiply the previous value times the dimension. So this is index dim in, okay, and I'm going to multiply 0 times index plus 0 times dim plus index. Okay, and then that whole thing is what I returned. I don't know, maybe I'm did I mean index? Reduce takes It's really this. Ugh. Okay. I'm passing in pairs of stuff. Does not support. Fix. Yeah, whatever. Okay. Previous. All right, let me comment this out. Okay. Oh boy. Do I believe? Okay. So you zip together the indexes and the dimensions. You take the initial value is that first index, and then let's call this previous, or is total. And then this is arg1 is I'm going to rename him to index dim. Okay, index and dimension. Pull it out that way. Fine. Return total times the dim plus the index. Okay. And my claim is this should work if I can find my test. Interpreter tests. It's the last test, right? Okay. So much for that. Index less than 0. Index out of bounds. How's that happen? Okay. Let's see. Let's look at indexes. Index dimensions is one value. What test is this? It's our test. Okay. Interpreter. Index is 2. Let's see indexes. Cannot find indexes in scope. Let's break here. Okay, so let's see expers. Number 1, number 2. Okay, 1, 2, good. If we step over, okay, we expect indexes to be 1, 2 as integers. Yep. Okay. Wow. Do I need to? I don't know. I think I'm in an off by 1 error. I is I is the index is sub 0, index is sub 1, and so on. Index is the value. Sorry, I is like 0, 1, 2. The index is the value. Okay, so let's print dimensions. Have we messed up the dimensions somewhere? Why, yes, we have. 11. So we've got a one-dimensional array, and we're trying to write two-dimensional values in it. All right, so let's go find dodim. Yeah, count is the array of dimensions. Dimensions gets put in as is. Let's see our implicit dodims. Maybe they weren't as good as they should be. Here's do assign. If global subname, oh, there, yeah, that can't work. Right. So if you have a multi-dimensional access, we need to know how many dimensions to create the name. Okay. Well, expers is the controlling thing. So let's this is really it's really we did it before. What was it? This thing. Okay. And yeah, this is ugly. Okay, count repeating 11. Is expers, what's do dim want? Repeating 11 for expers.count. Okay. And then should this be float? Yeah, it should be int. Okay. All right. And then we have the same thing somewhere else. Where's that? Okay, let's test our function again. All right, I will try and, well, let's look at dimensions and make sure it's right first. Yep, okay. Let's go ahead and try and continue. All right. Okay, now, oh boy. I think what we want to do, I'm going to write a little more complicated program. multi-degree array, full read and write. Okay, and we have the most horrid subset of BASIC right now, so I apologize, but I kind of want to write a loop. Okay, so let's start I equals 0. If I is greater than 10, then jump to 100. Okay. 30. A sub, oh, well, we need a J, right? J equals, sorry, let's do like 5. J equals 0. If J is greater than 7, then 100, make this 200. This is kind of a test of a lot of our code, really. All right, so I want to write stuff into IJ. Okay. B sub I comma J equals, well, let's add a counter. X equals 1. Default value is 0, so I want to start with something bigger. All right, X equals X plus 1. Okay, I'm going to keep that one incrementing. J equals J plus 1. I mean, this is even worse than what you had to do back in the day, I guess. At least they had for loops then. All right, so I increment J, and if it's, well, I guess I just want to go back to line 40. Go to 40. All right, so we are writing J 0 through 6, and if it's 7, we want to skip to 100. Okay, so we finished our J loop, and now we want to increment I, and go to 25. All right. Okay. I think that code should write the values from 0, 5 to and 0, 6 for J into the B array. All right. And now I want to print them all. All right. So I'm going to do the same kind of thing, but I'm going to have to adjust line numbers, so forgive me. Go to 25. Let's make this 220. Then I can just do these. All right. So if once I finish my I loop, I'm going to reset I, and then this is 300. Whoops. Pi greater than 5, then 400. And this is 300, I think. And for now. Okay. Restart the loop, and I'm going to print B sub I J. I don't need to increment X anymore. Okay, so if it's greater than 5, then go down here. If it's greater than 7, jump here, go to 225. And okay, well, that's the biggest program we've written. And what do we expect? Well, I think what we expect, we may have to tweak these limits, but I think we're going to get, we should get the same values back, right? 1, 2. Well, let's do it this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so this loop is running 0 through 5, which is 6. Oh, that's too many. Let's do 3. I'm trying to pick things that are relatively prime, maybe even 3 and 5. That gives us like 20 values still, right? I0, if I is greater than 3, so 3 is okay. So 0 through 3, 0 through 5 is 6. So 18 values, if I counted right. And the real thing is, I want to make sure the
accessibility shortcuts.
Well, banged something weird. 17, 18. I think you hit shift 3 times or something and you summon that. Okay. We'll just let it rip. Uh-oh. Have we got an infinite loop in our basic code? And no way to stop it. I don't think it could take that long to read 18 values, right? So let's double check our basic code. Oh my goodness. All right. X is 1, I 0. If I is greater than 3, no. J 0, J greater than 5, no. Write X in is 1, increment X, increment J is now 1, and go to 40. Okay, which does the check. If you run out of J's, so that should loop through here and assign everything with the second index. If you run out of J's, go to 100, increment I, and go back and write those. Okay, that seems plausible to me. If you finish I, then 220, where we kind of start over. If I is greater than 5 than 400. Okay, let's cut the problem in half, right? That's the old tradition. I don't know where I can put this. Down here. I mean, if there's an infinite loop, it should be in the first part as well. All right. And then we will okay. The output expectation is wrong, but if we get an infinite loop here, we're just as bad off. Okay. And I don't know what okay. One failure because it came back empty. No line number. No line number. Do I have to do this? No line number. Check program results. We've done this any number of times. Okay. Let's do a shorter problem. Check program results. Maybe it's that last one? Maybe it's the start of line versus end of line thing. Yeah, maybe I gotta do it like this. Okay, no line number. Everybody's got one. Maybe no line number is coming from an if statement? Coming from the go to. No line number. I thought we did go to. I think we did it pretty early on. Try go to. Okay. Well, if case integer let line number, then next token. Otherwise, go line number. Missing target. No line number. Line. Okay, if integer line number equals token, then next token. Okay, let's try the other way here. See if we can isolate this down. No line number is not equal to empty string. Okay. Token integer 60. That seems good. Maybe we screwed up some of our... I thought we straightened out this parse integer stuff. Okay, step. Okay, line number less than or equal to 0. Line number 60 is not less than 0. It's not greater than max line number. Maybe it's the... Go to line 40. Looks good. Okay. an end of line. All right, step over. Turn parse.line statement number. And we're interpreting it. Okay. Oh, we got to go to one line that doesn't exist. Okay. End of line. All right. Okay, in our test, 60 go to 40. There is a line 40. All right, so maybe interpreter. Let's check out this step, the go-to thing. Okay, so this, we're getting line 60, and it says it's a go-to 40. We set the line number to the line after 60, which in the case of an empty one is like default to 9999, whatever. We parse the line, go to 40. Everything looks good. Then we output step, go to, resets line number to the new line number, and we keep going with the output. Okay. Now, let's change this again. Let's make this go to 80. Okay. And then I expect the output to be 80. And I'm just going to continue. Okay. What print? No line number. Huh. All right, let's look at program. Maybe line after. Okay, I think that seems okay. If it doesn't find it, it says max line number. Okay, I don't know if this is the most efficient way to do this, but we sort the keys, we find the index of the current line number, and if we don't find one, we just say you're at the end of the program. If the index is if we're on the last line already, I guess basically if the start index is at the end, then you still get max line number. All right, and then otherwise you take the current index, the line you found, plus 1, and get that one. Okay, I don't know. That all seems okay to me. Let's. Now maybe there's something. Okay. We start with this one in there. I don't know. Okay, let's. Yeah, I think we're gonna have to look at this method. Okay, so we should see 60 go to 80. Parse is line. Okay. Okay, go to. So go to 80. All right. That seems okay. Okay, not done. The line should be 80. Print 80. Okay. Okay, I guess we're executing the print 80. Print, okay. Should be an 80. Okay. Now is the critical part. sure what we're doing here. Okay, print parse. Okay. 9999, that seems right. Okay. Oh, I don't know what line number. Still there. Okay. The parse is a line. Should be an end. Okay. We'll step in. And done is true. Return output. That's what we'd expect. Okay. Not done. We should be done. Okay. Continue. Now I'm all right. Let's take the breakpoint out. Let's take this out for a moment. Just run this one test on its own. I don't know if that build failed. Oh, okay. Messed up the lines somewhere, I expect. Whoa. Yeah, I don't know what if a line's not found. Okay, let's just put 100 end here. So that part should pass. I don't know what's going to happen here. Oof. Okay. So let's take this out. Yeah. I don't know why it doesn't want to take them out. Okay. Quoted strings, I guess. It's not really what I'm expecting, but okay. This part just worked, so I don't see anything there. Okay, now that's legit. If it has no line 220. Let's make sure that's there. All right, now it's not. Oh, okay. That much is fine. All right. $220, 100, 40, 25, 400, 300, 40. Ooh, that's a problem. Should be 240 and 225. Okay, that was probably it. I guess yeah, right. Oh. Oh, that built. Okay, let's run. Maybe we're checking arrays now. Okay, look at that. 1, 2, 3, 4, 5, 6, 0, 0, 7, 8, 9, 10, 11, 12, 0, 0, 13, 14, 15, 16. Okay. Now, what's the problem? So, let's see that output again. 6, and then 2 extra zeros, 24, and the whole thing dumped out. I don't see why I should have a different number of... Well, let's add our debugging in 241. Unfortunately, our prints are not sophisticated. 242 print J. All right. Let's make sure we're getting the numbers we expect, the indexes. So it should print like 0, 0. Okay, 0, 0, contents 1, 0, 1, contents 2, 0, 2, contents 3, 0, 3, contents 4, 4, contents 5, 5, 6, 0, 6, contents 0. So 0, 0 to 0, 5 is okay. 0, 6, content 0. All right, is that what I want in my loop? I expected I to be 0, 1, 2, 3, and J to be 0 through 5. why we're getting 0.6. Did I not change? I did not. Oh, jeez. 3, 5. Okay, let's try the same loop on both. And let's take out these excessive prints. Okay. Just work. It's the end of the session. You're supposed to just work. Okay. I think it's be closer. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 through 24. Is it my assertion that's wrong? It might be. Okay, 0, 0 to 0, 5. Sorry, the first index is 0. Yeah, let's do it this way. I'm writing on a piece of paper. Sorry. Okay, index I goes from 0 to 3. J goes from 0 to 6. 3 times 6 is 18, but it's 4 times 7 is 28, right? Oh, wait, 5. 0 to 3, 0 to 5. Okay, so it's 4 by 6. I equals 0 to 3. J equals 0.5, which means it's got 4 times 6. Okay, so I expect four by 6. Okay, 24 values being put in. And so I'm assigning each one in here. Yeah. Okay, I think this is both correct and running correctly. Oh, one failure. Expected start of expression. Now, what did I just change? Oh, I put junk in there. Okay, that's, yeah, 0 divided by something, right? So, okay. Oh, boy. Okay. It's getting beyond comic here. 22-24, not equal to. Is that a new line? Yes, it is. Hopefully I put it on the right side. Because each print prints a new line. Yeah. Oh my goodness. Okay. Wowzers. Okay, I'm gonna make this smaller. 2, 4, 2, 4. So that should be a 3 by 5. So 15. Okay. Well, I think we've done what we set out to do. And that's by far the biggest program we've tested. Sad to say. I'd like to get some real tests in, I mean real programs, and do them. But let's take this while we got it here. Multidimensional arrays. Okay. What we saw in this, the debugging process of that was painful, probably even more painful for you than me, but the messages we're getting just aren't that helpful, right? I mean, missing target, right? I'd like to know, like, what's the target? If 220 were missing, then it would be good to say, can't find line 220. So I think we'll just look around for a couple minutes and see where we're at. Let's get down to the very array access. I'm inclined to pull out a method for this just because yeah, I think we can do that. Oh, come on. What aren't you letting me see? The guard case, that does a return. They all do a return. Okay, we'll do it manually. Okay, clearly we need a store, a name, expressions, and we return a value. Okay. So name is a string, store is a store, expers is an array of expressions. Yeah, now this is odd. It's just I don't see any issue with it. All right, let's do, what do we call it? Store array value. Name, store, expers. We'll do a return on the whole thing. All right. Okay, so we did a refactor. I'll just check one more time. It's worth the 0.603 seconds. All right. So, I mean, what happens is it's all very flat. And I don't know how much that is inherent in it. But, everything is kind of going through this big case statement. Maybe I could I don't know. I tried a visitor and that just didn't really quite take, but a visitor would look like this too, kind of. So, all right. So I think we've done what we set out to do today, that we got the multidimensional arrays working. So dimension statements, expressions to access them, and expressions to write them all seem to be working. We wrote a substantial program and demonstrated that it's hard to debug BASIC and Swift at the same time. But it does at least check this array access and make sure everything is written properly and not overwritten or unique or wrong indexes or any of that. That's pretty good. Next time is tomorrow, 10 a.m. Eastern to 12:30 p.m. and UTC 3 to 5:30 p.m. We will pick up with the string arrays. And I think we're getting to the end. of our expressions. They support functions and arrays as well as all numeric operators and all that stuff. We got some control helper stuff, and then just a bunch of polish and cleanup, I think. Fancier print, okay, line numbers. Maybe the error message stuff would be a good thing. I'd like to get to the point of trying this amazing maze program and see if we can get that running. I know it needs on go to and for next and go sub return. So we get these control structures, and that might be a doable thing. Anyway, thanks for joining today. I hope I can catch you in the future, and have a good evening. Take care. Bye bye.